Scientific breakthroughs change the world, but when experiments, machines, and organizations ignore risk, the consequences can be catastrophic. In the next 4 minutes, we'll revisit 4 scientific and engineering accidents, not for shock, but to understand the chain of small decisions that can turn progress into tragedy. April 26, 1986. At the Chernobyl nuclear power plant in Ukraine, operators prepare a late-night safety test. Could the turbine's momentum power emergency pumps during a blackout? A dangerous mix of reactor design flaws and procedural violations pushes the core into an unstable state. In seconds, power surges. A steam explosion tears open the reactor. Fire and radioactive material rise into the night. First responders fight flames without understanding the invisible hazard. Nearby communities are evacuated too late. And the fallout, medical, environmental, and political, spreads far beyond the plant, shaping nuclear safety for decades. Chernobyl and Challenger happened in the same year, 1986, on opposite sides of the world. Different systems, same theme. Complex technology plus human pressure can outrun safety margins. January 28, 1986. The Space Shuttle Challenger lifts off into cold Florida air. Just over a minute later, it breaks apart in front of millions watching live. Investigators trace the failure to rubber O-rings in the solid rocket boosters, seals that could stiffen in low temperatures. Engineers had raised concerns, but schedule pressure and miscommunication turned warning into noise. Challenger became a lesson in normalization of deviance. When near misses feel routine, organizations start treating risk as acceptable, until it isn't. In the mid-1980s, a medical device called the Therac 25 delivered radiation to cancer patients. Unlike earlier machines, it relied heavily on software and removed several hardware safety interlocks. Rare race conditions and user interface quirks could trick the system into delivering massive overdoses while displaying normal readings. Patients reported burning sensations. Some suffered severe injury or died. The tragedy exposed a dangerous myth that software errors are less real than mechanical failures. The fixes weren't just patches, they were new practices, independent verification, fail-safes, and a refusal to treat anomalies as patient error. September 30th, 1999. In Tokaimura, Japan, workers in a fuel processing plant shortcut procedure while preparing uranium solution. Too much fissile material accumulates in the wrong container. A criticality accident begins, an uncontrolled nuclear chain reaction. A blue flash, intense radiation. Emergency responders scramble to understand what's happening in real time. The event forces evacuations, exposes workers and nearby residents, and reveals a familiar pattern. When processes are complex, safety depends on training, culture, and systems designed to make the wrong action hard to do. After every disaster, the question is the same. Do we learn only the technical failure, or do we fix the culture that allowed it? The difference determines whether the next near miss becomes the next headline. These stories differ in technology, but the pattern rhymes. Hidden design weaknesses, unclear responsibility, silenced warnings, and safeguards removed for convenience. Real safety isn't a slogan, it's redundancy, transparency, testing, and the courage to stop. If you want more videos like this, tell me which accident we should cover next, and what lesson you want to pull from it.